You intend to estimate a population mean with a confidence interval. You believe the population to have a normal distribution. Your sample size is 9. While it is an uncommon confidence level, find the critical value that corresponds to a confidence level of 80.8%. And report your answer accurate to 3 decimal places with appropriate rounding. So since we believe the population to have a normal distribution, we can use a t-curve when we are estimating our population mean. And we're asked to find a critical t-value so that we have 80.8% of that curve landing between t and its opposite on the other side of the curve. What does that leave us for the tails? That leaves us 9.6% of the data in each of the tails, because remember, this is a symmetrical distribution. Okay? That means that we have 90.4% of the curve to the left of this t-value right here, the critical value that we are asked to find. To find a critical value, we're going to use the inverse t function on the calculator. So for that, we want this distr is what we want. So we'll do second bars to get that. And inverse t is the 4th choice, so we'll hit 4. That comes up with inverse t and the beginning of parentheses. It needs 2 inputs from you to find the t-value you're looking for. The first thing it needs is the percentage of that curve that is to the left of the value you're looking for, expressed as a decimal, not a percent. So that's 0.904 in our case. The next thing it needs is the degrees of freedom. Remember that degrees of freedom are n minus 1. In other words, sample size minus 1. In our case, the sample size was 9, so the degrees of freedom are 8. Remember to close parentheses, we'll hit enter. It'll think for a minute, and it will give us a critical value of 1.425 if we round it to 3 decimal places. So our answer for the critical value that corresponds to a confidence level of 80.8% with that sample size of 9 is 1.425.